Welcome to today's lecture. This is Blessed Elvis. So in today's lesson, we are going to discuss how we can differentiate given different functions using the power rule. So a function can be represented as f of x, or it can be represented as g of x. It can also be represented as h of x. So either of these represents a function, and all of these functions that we have here represents the function of y. So we can differentiate different functions that we have been given using the power rule. So apart from the word differentiate, the other term that can be used is the derivative. So the derivative, or rather differentiation, can be represented in many forms. The first one, it can be represented as dy over dx. The second one, it can be represented as the y prime. Okay. Apart from this, the last one, it can be represented as the given function prime. For example, if you have been given f of x, then this can be represented as f prime of x. Okay, apart from f prime, let's say for example a function has been given as g of x. So for you to differentiate this can be written as g prime of x. So that's what I mean by this one. It's not only f, they can use different letters. So mainly, the main concept behind understanding the different forms of differentiation is that differentiation can be presented in these three forms. So they may not say differentiate, but if they say find dy over dx, this simply means you have been asked to find the derivative. If you have been asked to find the y prime, it simply means you have been asked to find the derivative. If you are also being asked to find the f prime of x, it means you have been asked to find the derivative, or rather the differentiation of the given function. So let's look at some of the examples we use. Now, before I go further, let's look at a rule that we use. So let's say you have a function, a certain function f of x equals to x power n. So what's the general concept behind differentiation? So the general concept behind this is that when you are differentiating this, since we have this, if you want, you can write this as dy over dx, or f prime of x, or y prime. Either of those is just okay. So here I will just use dy over dx equals to, so to find dy over dx of such a function, you write this power here in front of the given function, or rather you multiply the power with the base. So in this case, it's going to be n multiplied by x, which is going to be n x. And then you subtract 1 from the power. So it's going to be n minus 1. So this is the differentiation of the function given above here. So let's look at some of the examples. So let's say you have, let's say y equals to x squared. So if you have such a function, to differentiate this, you simply have to, so here we are going to use y prime equals to, you simply have to multiply this power here with the base here. So this power squared multiplied by x, it's what? It's 2x. And then subtract 1 from the power, we're going to have 2 minus 1. Let me just write this properly. So we're going to have 2 minus 1. And of course we know that this case y prime is going to be 2x, and then 2 minus 1, it's simply 1. So in this case, finally this can be represented as y prime equals to 2x, because any number or variable raised to power 1 is simply that same variable or number. So this is the differentiated expression of the given expression that we had here. So let's look at some of the other examples that you might have. So let's say we have f of x. Let me just use a different function. Let's say we have g of x equals to, let's say we had 3 and then x raised to power, let's say 3 there. So to differentiate this, we are going to find dy over dx of this. Of course, this is going to be multiplication of the power, that is 3 multiplied by this 3 here. We're going to have 9x. And then we subtract 1 from the power, that is 3 minus 1. So in this case then, the dy over dx of this function is going to be 9x, and then 3 minus 1, it's 2. So this is the differentiated type of an expression. So let's say again we had many of these, so you can have more than one of the functions that you are given. So let's say in this case we have f of x equals to, let's say, 2x raised to power 3, and then plus, let's say, 3x squared, or rather let me just say, yeah, x squared, and then minus 4x. So how can we differentiate such kind of an expression? So in this case, differentiating this is the same as we are finding the f prime of this function that we are given here. So in this case, this is going to be f prime of x equals to this power here, that is 3 multiplied by the base 2, you're going to have 6. So 6x, and then subtract 1 from the power, that is 3 minus 1, you're going to have 2. And then plus this 2 here, that's the power, multiplied by the base, that is 3, it's 6. And then 2 minus 1, we're going to have 1. And then minus. Now, we know that any variable or number which does not have a power, it means there is a power of what? Of 1. So even if they haven't shown here, it simply means there is a power of 1. Okay? So in this case then, it's going to be 1 multiplied by this 4 here. We're going to have what? We're going to have 4x. And then this one again, subtract 1. So that is 1 minus 1, it's going to be 0. Okay, so 0. So in this case, going further, we're going to have f prime of x equals to 6x squared plus 6, okay, plus 6x. We know that even if we don't write the power 1, it's just the same as just omitting it. So we're going to have negative 4. And then we know that anything raised to power 0, it's 1. So in this case, we have x power 0, which we know x power 0, of course, it's going to be 1. So in this case, this can be represented as f prime of x equals to 6x squared plus 6x, and then 4 multiplied by 1, we're going to have what? 4. So it's going to be negative 4. So this is the differentiated type of the expression. So let's look at one last example. Let's say we have a function that is h of x, let's say equals to, and in this case we're going to have 4x raised to power 4x raised to power, okay, raised to power, let's say 4, and then minus here 2x raised to power 3, and then we have, let's say, plus, let's say we have x squared, then minus, let's say, 3x, and then plus 4. So what do we think this is going to be? So in this case, we are differentiating this, so we can represent this as h prime of x equals to, now 4x, rather let's just multiply it further. So multiplying this power 4 multiplied by the base, we know 4 multiplied by 4 it's 16, so it's going to be 16x, and then 4 minus 1, it's what? It's 3. Then minus this 3 multiplied by this 2 here, we're going to have 6. And then 3 minus 1, it's 2. Okay, then plus, here we don't have any coefficient of x, so it simply means there is 1 here. So in this case, this power 2 multiplied by 1 here is going to be 2x. And then this power 2 subtract 1, it's going to be 1 here. Then minus this x here doesn't have a power, so it simply means that we have 1 here. So in this case, 1 multiplied by 3, it's 3. So it's going to be 3x power 0. Because 1 we have here, subtract another one, we're going to have what? We're going to have 0. We have done this before. So in this case, whenever you have a constant number which does not have a variable, you simply omit it. So this positive 4 is simply going to be ignored. So in this case, we're going to have h prime of x equals to 16x. We are already done this, so I'm just going to rewrite them. Then plus 2x. So power of 1 can simply be written as 2x. So in this case, minus 3. As discussed before, x power 0 is simply 1, because anything raised to power 0 is 1. So in this case then, h prime of x is going to be equal to 16x raised to power 3 minus 6x squared plus 2x minus 3. So this is the answer. Thanks once again guys for staying this far. Please like, subscribe, share and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.